Okay, so what we're looking at here, right, these headings, the way the titles work in my class are, this is geometry, it's semester 2, this is the first unit called trigonometry. In the unit there are 8 lessons, this happens to be lesson number 3, this lesson is abbreviated, cosine, alg, and inverse practice. And when you match up this video with the assignment you do, that's the title you're looking for right there. And I'll put that into the post too, so you can match up the titles. This is all on Creator Math, right? That's where you're finding this, under the Geometry tab. And then here's the directions for this assignment. Copy the following problems into your composition book on the correct pages according to the table of contents with the notes from those pages. Don't forget the notes, because that provides a lot of background material, and it's all from Creator Math there where you can find it all. Go ahead and open a tab for it or bookmark it, whatever you need to do to keep it up on top. Okay, this should start to look repetitive. This says, given the figure below, what is the opposite leg or op leg for the given reference angle? Some important things in this question are reference angle. That's something important in trig. And this idea of op leg or opposite leg. It's called opposite leg, and I abbreviated op leg because I'm too lazy to write opposite. Right, so op leg. Now, this is a right triangle. How do I know it's a right triangle? Because of the 90-degree symbol down in the corner. Every triangle has 3 sides, and they have names. A triangle has 2 legs, like a human, you guys, and the 2 legs are attached, or adjacent, or next to, or touching the largest angle, and in the case of a right triangle, that's the 90-degree angle. Why is 90 degree the largest angle? Even though you don't know these, the sum of the angles of a triangle is 180 degrees, so 180 minus 90 would leave you with 90 divided by 2 here, right? So these have to be smaller than this overall 90. So this is the largest angle. 2 legs to a triangle. This is asking where's the op leg to the reference angle. In this case, the reference angle is an alpha. That's the Greek letter A. And we often use Greek letters as variables for angles. So we use alpha, beta, gamma, phi, different ones we use, okay? So, but this one's alpha. I just want to focus you on the biggest one first, and if you know what alpha is, you can be on your way to understanding the other variables. So this determines what in trig we want to know what angle we're focusing on. That's what's called a reference angle. So alpha is focusing on this angle. We know this is 90, and this one's blank. We don't care about it. We're ignoring this angle. So of the 3 angles, there's only one we're interested in. That's the reference angle. They want to know what the opposite leg is from that reference angle. Once the reference angle moves, the op leg is going to shift positions. So looking at the reference angle, opposite in geometry means across from, comes straight across from this, okay, to side A. That is the op leg. It's one of the legs. So I know it's side A. Why is it not side C? Because side C is not one of the legs, for one thing. Side C is that third side called the hypotenuse. Hypotenuse is the longest side, and you can see visually it is, and it's across from the largest angle, which we said here is 90. Okay, fair enough, so side A. Given the figure below, what is the adjacent leg to the reference angle? So let's go a little quicker. Here's the reference angle, alpha. It's one of the legs, 2 legs like a human, and it's the adj. Adjacent means in geometry next to. So if 2 homes are adjacent to each other, they're on the same side of the block next to each other. All right, that's different from opposite. Opposite means across from. If it were 2 homes opposite each other, they'd be on the other side of the street from each other, right? So adj leg in this case is the adjacent leg. It's the one next to the reference angle here, and so it's side B. Okay, somehow this seems really complicated, but once you know it, you might find it quite understandable. That's what I'm hoping for. That's what we're going for here. All right, given the figure below, what is the hypotenuse or hype? Now back to the discussion we just had. Every triangle has 2 legs like a human, and that's attached to the largest angle. And the longest side, opposite the largest angle, is the hypotenuse. And notice it's spelled hypo, 10, use. If you want to spell this word, and I do this every time I spell it, I do hypo, I do 10, and I do use. 3 words that together I can now spell the word hypotenuse. Now you're going to spell it hypo, 10, use, but you're going to pronounce it smoothly, hypotenuse. Okay, that's side C. Now they're asking us specifically about the reference angle, which we've already been using. We know it's alpha. In this case, we're using alpha as the reference angle. That's all they want to know. Given the figure below, what is the reference angle? And that always stumps students. They're like, how do you know what angle we're talking about? Well, they're going to use some symbol, some way of indicating, and that becomes your reference angle that you're now dealing with or talking about. Given the figure below, what's the opposite leg or op leg for the given reference angle? So a interesting thing about trig is when the reference angle moves, so remember before the reference angle was over here, now all of a sudden the reference angle has moved. Once the reference angle moves, the op leg changes location according to this reference angle. Op still means across from, and it still means a leg. Two legs, like a human. So not that one, that's the hypotenuse. Across from the reference angle now is side B. And if you remember, when the reference angle was down here, the op leg was over there, side A. So that's something that's hard for students to deal with. They're like, well, wait a second. You just told me the op leg was side A, but that's because the reference angle was here. Once the reference angle moves, the op leg moves with it. It is in reference to that angle, that op leg, so side B. And now that they ask us the op leg, they're going to ask the adj leg. And this homework assignment looks a lot like the last one. It's very repetitive. The idea is once you see it once, you can start to nail this stuff down in your mind. Given the figure below, what is the adjacent leg for the given reference angle? Again, the reference angle has moved to here. The adjacent leg, or the leg that's next to the reference angle, is side A. Can't be this side, right? This is not a leg. This is the hypotenuse, so it can't be that one. And I know because students will go, wait, there's two sides of the triangle that are adjacent to the reference angle. True, but only one is a leg. The other is the hypotenuse. Fair enough? Side A. All right, where's the hype? So now this is illustrating that although the reference angle has moved, in terms of the sides of the triangle, the one named hypotenuse, it is always the same. It does not move. So while the op leg and adj leg change depending on the reference angle, the hypotenuse is the name of a side, and there's only one of them. It's the longest side across from the largest angle. Okay, across from, right, means opposite. Opposite the largest angle. Side C is the hype. It was the hype before, and it remains the hype now. And again, we spell it hypotenuse, but we pronounce it hypotenuse. All right, given the figure below, what is the reference angle? They're just trying to get us to say alpha again. Everybody say alpha. Okay, good, thank you. Here we're focusing on the fact that mainly trigonometry, sine, cosine, and tangent functions, and you might try to say those. Everybody say sine, cosine, and tangent. Those are they all deal with 90-degree triangles. They want us to just say, hey, all these triangles are right triangles. But keep in mind, we're going to do the two last lessons. We'll do the law of sines and the law of cosines, and those do deal with non-90-degree triangles, right? But what they're trying to get us to say is, hey, trigonometry mainly deals with 90-degree triangles. All right, let's go to this. The all-famous sohcahtoa. Everybody say sohcahtoa. Okay, good. So, S-O-H, ka, toa. So, S-O-H, ka, C-A-H, and toa. This is the all-famous acronym that helps us remember the three trig functions, sine, cosine, and tangent. So here they are up here, right? Sine, cosine, and tangent. The S is for sine, the C is for cosine, and the T is for tangent here. And we say it, sohcahtoa. Let's get into what it means. Let's take cosine here. So the definition of the cosine trig function, cosine alpha equals, here's what it is. Cosine alpha, and I'm going to use alpha as a variable. We don't know what that angle is, but it represents an angle, equals. There's an equal sign in the statement, and this is a definition, folks. See it up here? C, ka, is cosine equals adj leg over hype. It's written like this. Adj leg over hype. That is a definition. All right. So sohcahtoa, we're using that to remember this, and here it is here, adj leg divided by height. That is a definition. Memorize it, but memorize more sohcahtoa, because that'll help you get back to this. Right. Most students will start to mix all these three functions up, and it gets really complicated for them. But not if you remember sohcahtoa. Right. Now, they're going to ask us to apply this trig function. So for the following figure, what is the proper setup using the cosine trig function? So here it is. Cosine alpha equals, let's see, adj leg, right? Just like ka. Adjacent leg, I'm going to abbreviate it adj leg over height. That's a definition. You'll see me write it over and over and over. Here is our reference angle now. They didn't use an alpha, but they totally clued us in on which angle they're interested in. According to this angle, there's an adj leg, and that's why we describe the different locations of the sides. There's two legs like a human, and this adj leg is 7. So in this whole thing, adj leg goes on the top of the fraction, and the height, which is the longest side, which we also identified, is 15. This is a length, 7 and 15. It could be miles or inches or whatever. We don't know the angle, so we're going to say cosine alpha. This is how the trig function is set up, and that's your first step in solving these. All right, so we're going to circle this one. And notice on the last lesson they were talking about sine. Now they're talking about cosine, and eventually we'll talk about tangent. All right. So for the following figure, what is the proper setup using the cosine trig function? They want us to do it again. Let's rewrite it. Cosine alpha equals adj leg over height, and that's in the ka, and sohcahtoa, right, is the cosine. Cosine, this is the angle involved here. This one's ignored. Nothing over here. We don't care about the 90. We already know it's 90, so that's fine. And we know it's a right triangle, so we can use the cosine function. So question here, cosine angle stays in there as a variable. We have the adj leg 7, right, and over 15. Now, the interesting thing they've done here is they've gone ahead and tried to introduce to us what's called an arc cosine. And how this works is, let's say we don't know the angle alpha. We can rewrite alpha as a variable, like saying x equals, but alpha equals. And we can move the cosine function over here. So we've got cosine to the -1 of this fraction, right? So once you move it over here, it takes on a -1 and it separates it from the angle, and it then drops in 7 over 15. And I think I'm going to have some time this time to show you the use of the calculator. Let's do 2 more problems, and then I'll go back to one of those. And guys, get your phones ready, because I'm going to show you the calculator on the phone, how to find trig functions on your phone using the calculator app that's already built in for you. So for the following figure, what's the proper setup of the trig function? Now, interestingly, they give us the angle. We know we're dealing with cosine because that's for this lesson. Later, we'll have to figure out it's an adj leg and a height, and therefore we're dealing with cosine. Cosine 27 degrees, because that's the angle. And I should probably write the generic cosine alpha equals adj leg over height first. That's our formula and our definition. Memorize it, or just remember sohcahtoa. Cosine 27 degrees equals adj leg is 5 in this case. It goes on top of the fraction. And in this case, we don't know the height, so we're going to make it x. And later, you're going to be able to use your cross multiplying technique, and you're going to be able to switch the x over to here, keep the 5 on top, and drop this cosine 27 all together underneath it, and we're going to be able to solve for x equals. In fact, we'll have to say approximately equal. Maybe I'll do that on the calculator. Let's see. But what they want for this assignment is cosine 27 degrees equals 5 over x. All right, last one before we try to use the calculator. For the following figure, what is the proper setup of the cosine function? Cosine alpha equals adj leg, which stands for adjacent, over height, which stands for hypotenuse. I know the angle. They're giving us 27. Cosine 27 degrees equals, in this case, the adjacent leg is the x. I don't know, so I'm calling it x. I do know that the hypotenuse is 14, so 14 here. And again, here we can multiply using equation solving methods. We can multiply both sides by 14. 14 over 14 is 1, and we end up with x equaling 14 cosine 27 degrees. All right, with that said, let me keep my 4 cleaner here. With that said, let's see if I can pull this off. All right, this is my calculator right here, right? If I open this up, I get a simple calculator, 9 times 8 is 72 kind of thing, right? But what I want to be able to show you is you need to have your landscape lock off, turn your phone on the side, And now you're going to see a far more complicated calculator. I'm assuming you knew this was there. All of your calculators have it, whether you have an Android or an Apple. This is the way it works. Now your calculator will be slightly different. Apple kind of runs its own calculator. And that's okay, it'll be fine. You're just going to learn to use yours. First things first, there's something here called radians. Notice how it shows radian on the screen right here, or degree. You need to be in degree mode to do these basic problems. When you get into Algebra 2, you're going to use radians, and don't worry about it for now. Just go make sure I'm in degree mode. If you see a rad up there, RAD, stands for radians, switch out of it, make sure you're in degree. Right? Notice, look, sine, cosine, and tangent. And you guys, when I was in geometry in high school, I thought it was the funniest thing that in math class we talked about sin, S-I-N. I was like, what is this, church, all right? We're talking about sin in geometry class? Well, it's abbreviated for sine, okay? Just so you know, it's sine, cosine, and tangent, all right? I'll leave that discussion up for your pastor or church or whatever, right? Okay, so here's what we're going to do. Let's take this first problem. Let's see if I can lay this down where you can see both. We set this up using the cosine function. I can go a little higher. What if I do this? All right. Not perfect, but okay. We set this up as cosine alpha, right? And we're using the adj leg over height. We put it in place. We use some algebra to move it down. Now we have x equals 14 times cosine 27 degrees, and that's why we wanted it in degree mode. So what I'm able to do is use my cosine trig function on my calculator. See how it says cosine? It's 27 degrees, so I'm putting in a 27. I'm going to close the parentheses. So notice if it were like a parentheses here on the 27. And then I'm going to multiply this because it's times 14. And I realize mine's out of order, but remember we can, multiplication can be flipped forward and backward and we get the same answer. What do we get right here? We get 12.47, and I'm going to go to two places. I'm going to move this down a little, and I'm going to say x equals 12.47. What is that? That's the length of this unknown side. And this is the brilliance of trig. By using these trig functions, we can, having one unknown side, and an angle and a given side, we can find out the length of the unknown side. This side is 12.47 long. So see how this is 14, the longest side? It makes sense, 12.47 here. All right? Go up and let's see if I can put all of this in the screen, and let's try to put this into the calculator. And notice that I should be saying approximately equal, because if you see all the number of decimals here, see how these go on and on? I can't say it's equal to 12.47. I have to say it's approximately equal to 12.47. It's not exactly equal because of all these digits that keep running out beyond the decimal. Right? So to be more accurate, let's say approximately equal, which you take an equal sign and you make it squiggly, like that. That's approximately equal. All right, let's see. This calculation is 5 divided by cosine 27. Let me clear this out. 5 divided by cosine 27. And I'm going to close the parentheses, although it doesn't really look like I have to. It's already come up with 5.61. This is approximately equal to 5.61. So in this case, it's the hypotenuse. The hypotenuse here is the longest side. This was 5, and this is longer, 5.61. So I'm okay with this answer. That's the actual using my calculator to find it. I want you to first do the problems and do them in your comp book, and then go back and try to use your calculator, you guys. This is going to be fun. And if it's an Apple, you might have to type these in a different order. All right, but I'm going to either let you play with that, or you can ask me in class, and I'll do my best to help you. Okay, let's do this one. Let's say alpha here, and I'm going to say approximately equals. This is the inverse cosine of a fraction. Watch this. Clear this out. Go to your second screen. See the second here? Go to the second screen and look at this. The trig functions show up with a -1 to the power -1. That's called an inverse or an arc. So I need inverse or reverse cosine. It reverses it. I'm going to use inverse cosine, and it shows a cosine, stands for arc cosine. They abbreviated it a cosine. And this fraction, 7 divided by 15. 7 divided by 15. And close the parentheses, although I didn't have to. It is now giving me an angle, because alpha here represented the unknown angle. The angle is 62.18. Okay, and that's degrees because we're in degree mode. So this angle right here, across here between these two sides, is 62.18 degrees. And that's the brilliance of trig. This is what trig allows you to do, is to figure out missing side lengths and missing angles on right triangles. And we love it. So I hope that helps. Make sure you're finding this stuff at creatormath.com.